Projectile motion. A projectile is an object in free fall. Now, we did free fall last year. I mentioned I jumped out of an airplane. But that was in one dimension. Last year, we let it go straight up and come straight back down. This year, we're going to do two-dimensional projectiles. So here's our first thought puzzle. Let's suppose a mass, better yet, my Nerf dart gun. Let's suppose I take my Nerf dart gun and I hold it shoulder high so that it's pointing exactly horizontal, level with the ground, and I pull the trigger. Which of the four paths that I've drawn there is the projectile more likely to fall on its way to the ground? Path A, it's going to go straight down. Path B, it's going to go like that. Path C, it's going to go straight for a while and then gravity will catch it and pull it down. Or path D, it's going to go straight and then drop. See the four paths? You know what? Let's vote. How high you hold your hand up is how sure you are of the answer. So we got four options, A, B, C, or D. Who says, Mr. Dewick? No, path A, clearly path A. A. I got one A. Who says path B, Mr. Dewick? B. 1, 2, 3, 4, 5, 6. Who says path C? 2, 3, 4, 5, 6, 7. Who says path D? Carter, talk to me.
I believe that
Why?
when you shoot it, gravity's acting on it instantly as soon as it's out of the gun, and therefore it's constantly going towards the ground.
You're correct. Now, it's not your fault. Those of you that picked C, first of all, those of you that picked A or D, those of you that picked C, it's not your fault. Movies have lied to you because almost all of you have watched a movie that had a sniper. And the classic camera scene, they show the sniper looking through the scope, and apparently all you need to do to be a sniper is to just line up that little X on your target. No! That's all it took. Any idiot could be a sniper. In real life, the bullet starts to drop as soon as it leaves the gun. Gravity is acting on it. And so in real life, for a target that's a long distance away, a sniper might be aiming a meter or more above the target because it's going to drop in the time it takes the bullet to travel there. Hollywood has taught you that bullets travel in straight lines. They do not. As soon as they leave, they're dropping. Okay? Question card? No? Okay, next thought puzzle. Suppose I have two identical objects and they're held at the same height above the ground. You know what? Let's go back to my Nerf dart gun again for one of them. Suppose I had a Nerf dart. We're ignoring air resistance as always, Aiden. Suppose I had a Nerf dart in my right hand. Here we go. And at exactly the same moment as I pulled the trigger on my Nerf dart gun, I dropped this dart. Which one hits the ground first? Option A, object 1 will hit the ground first because it has a shorter distance to travel. Option B, object 2 will hit the ground first because it's traveling faster. Or option C, they both hit at the same time. Question?
The one that you shoot, is it like the time from the gun?
Let's say it's from the second it leaves the barrel. Good point. Although probably that's minuscule enough that it might not make the difference that you think. Let's vote again. Once again, how high you hold your hand up is how sure you are of the answer. So who says, Mr. Dewick, obviously object A is going to hit the ground first because it's got a shorter path. We missed you when you were away. We really did. Who says, no, object B, it's got velocity. It's got a kick to it, Mr. Dewick. Object B. Who says C? C is correct. Why? Why? That's the theme of today's lesson. So by the end of today's lesson, you should be able to give a good explanation. I think I got a video. I do. Put your pencils down, look up. The key to realize this question here is to realize vertically they're both doing the same thing. What's VI vertically of the first bullet? 0. What's VI vertically of the second bullet? 0. I know it's traveling horizontally, but vertically hasn't started falling yet. So they both have the same VI. They both travel the same vertical distance. Well, if you drop identical objects from the same vertical distance, of course they'll hit the ground at the same time. Of course they will. The horizontal and vertical components of a projectile are independent of each other. They don't affect each other. What happens horizontally doesn't affect what happens vertically. So if you break things up into components, you can move from analyzing the situation vertically, or you can analyze the situation horizontally. Both are equally valid. In this demonstration, they both have the same vertical motion, so they both hit the ground at the same time. Key idea. Don't write, this is not in the notes. What's the vertical acceleration of any projectile? You all know this from Physics 11. Objects in free fall at an acceleration of negative 9.8 meters per second squared. Okay? Vertically. What's the horizontal acceleration of a projectile? Well, the reason there's a vertical acceleration is because there's an unbalanced force acting on it. What do we call that force? Get the obvious one. Okay, gravity. If we ignore air resistance, and Aiden, we're going to ignore air resistance, are there any forces once the bullet leaves the gun, or once the ball leaves your hand, once it's in the air, are there any horizontal forces acting on it if we ignore air resistance? Noah, you shook your head, so say it. No. If there's no horizontal forces acting on it, if the net force is 0, what must the acceleration be exactly? Ariana was in Physics 11 last quarter, so it's fresher in her brain. Hey, if the net force is 0, what must my acceleration be exactly? Loud and proud. Noah, horizontal acceleration is 0. What's the vertical acceleration? 9.8. Negative. Well, you know what the horizontal acceleration is? 0. And I can prove it to you before you turn the page. A few ways. First of all, this was released recently. This is the key idea when we're analyzing projectiles. Vertical acceleration, negative 9.8. Horizontal acceleration, 0. In fact, typically what I'll do is I'll divide my page into half. On the left side, I'll do horizontal. On the right side, I'll do vertical. And I almost jot those two things down without thinking about it. Now, here's what that means. If you look at a projectile from the side in kind of a strobe photography view, turn the page. So here's a projectile that's been launched horizontally from a cliff. You can break it up into horizontal and vertical components. Karn, do you notice the vertical chunks are getting longer? Because it's accelerating vertically, gravity. But do you notice the horizontal chunks just stay the same length? Because there's no acceleration horizontally. So if we look at a stop-action strobe picture of a projectile, we find it's moving at a constant horizontal speed, but its vertical speed is not constant. Why is this? No horizontal force, so AX equals 0. I need to make this a subscript. There is a vertical force. What's the vertical force called? Starts with letter G. gravity. So AY equals negative 9.8. For a projectile, and again, this is ignoring air resistance, because you're right, in real life, air resistance would be a horizontal force slowing it down. We're ignoring that. What's my horizontal acceleration, Karn, is a number exactly? What's my vertical acceleration? Negative 9.8. The biggest issue for all of you is you're going to want to put that negative 9.8 into a horizontal equation, because it's going to creep you out not having any acceleration. And there's an A in the equation, Mr. Dewick, so I have to put a number in there. Yeah, a 0, which makes the math way nicer. Okay? Now here's what else that means. If we're talking about velocities, since AX is 0, VX is going to be constant. A VY will be changing. On the way up, it'll be slowing down. On the way down, it'll be getting bigger. Is that okay? Give reasons for your answer. Why is VX constant? VX is constant because, Karn, AX is VY is changing because AY is what, Karn? Unless we're on another planet. It's little g, whatever it is on your planet. Okay? So that little trampoline video that I showed you was pretty good, but we can even extrapolate that one step further. Here's a stop action picture, side view of a projectile. It says, at each point along the path, indicate the velocity components. So we're launching it, don't write this down, but we're launching it at an angle. Did I say angle? We would break it up into Vx and Vy initial. Why did I put an initial on the Vy but not on the Vx? Karn, what's my horizontal acceleration exactly as a number? So Vx initial is Vx final. It's constant. It's not changing. Is there a vertical acceleration, though? This is going to change. Okay? Let me shrink this diagram down a little bit. So I did a smaller version. Here's the point. The horizontal velocity is constant. It's not going to change. So if I draw that component right here, it's going to be the same length as the Vx on the ground. Here, it's going to be the same length. Here, it's going to be the same length. And here, it's going to be the same length. Same component. Allie, you're with me? You're not foolishly working on homework and this at the same time, are you? No. That would be silly. Okay. Right when I launch, my vertical component will be at its biggest. On the way up, what's going to happen to the vertical velocity? So, smaller than initial. In fact, right here, that's the velocity. If I add those two together, tip to tail. Don't put that blue line in. I'm just interested in the components right now. What about at the top for a split second? What's my vertical velocity? 0. Now, does that mean that my overall velocity is 0? No, there's still a horizontal component. And so that's the new part this year when we go two-dimensional. Last year, you all learned, well, at the top, V is 0. Vy is 0. Vx, nuh-uh. Then on the way down, that would be Vy. And right when it hits the ground, it'll have the same velocity as it left, but in the opposite direction. If it was launched at 80 meters per second, 30 degrees above the ground, it'll hit at 80 meters per second, 30 degrees below the horizontal. Oh, again, if we ignore air resistance, which McKenna, we're gonna. Okay? So it says indicate velocity components in the stop action picture and then fill in the key facts about two-dimensional projectile motion. So if we were going to break this up into components, did I say components? Sorry, did I say angles, components? I would break this up into Vx and Vy initial. At the top, Vx is still the same. What's Vy at the top? What about when we get even with the launch? Vx is still the same. Whatever it was. What can you tell me about Vi when I get even with the same height as I started? Carter, loud and proud. What? I didn't notice anything. You're all imagining things. Wind warning. Okay. So in other words, if when you did the if when you did the trig over here, you found that Vy initial was 6.8 meters per second, when we get back to the same height we started from, Vy would be negative 6.8 meters per second. Vx is still the same. What about when we hit the ground just before impact? Well, same. And Vy would be at its largest. I don't know what, but it would be negative, but bigger than 6. Its magnitude would be larger. This situation here, by the way, launching from the cliff at an angle, is going to be our toughest one to deal with. The easiest is the first one that I did with you, launching horizontally from a cliff. You'll find that one's pretty easy to deal with. In fact, I almost, if I'd had time, I would have snuck that into Physics 11 if we hadn't gone remote learning. This one is going to require components. This one's going to require components. So, horizontal speed is constant or changing? Because A is, okay. Because AX is 0. Vertical speed is constant or changing. Because AY is negative 9.8 on the Earth. I'm going to use X and Y for horizontal and vertical. May as well abbreviate. And the nice thing here is, Aiden, horizontal and vertical motions are independent. But what that really means is the by far most common error, and this is one I will go cuckoo for Cocoa Puffs over, don't you dare put a horizontal value into a vertical equation. Don't you dare put a vertical value into a horizontal equation. Vectors matter. Direction matters. You got the setup? Let's dive in. I like example 7. I like example 7. I like example 7. Example 7 is a nice question. And I'd like to introduce you to the big tool for projectiles. If the big tool for forces was, this is a job for a free body diagram, winner minus loser. The big tool for projectiles is what I call a T-table. Why do I call it a T-table? Because it looks like a letter T. And I put horizontal on one side, except I'm not going to write horizontal. I'm going to put an X if I'm doing this myself. I write vertical in the heading on the other side, big Y. And then I write down what I call two physics no-brainers. I write down AX equals 0 and AY equals negative 9.8. Now, I'm going to call them our physics no-brainers. They're not no-brainers. You have to know physics. But what I really mean by that is, hey, I can write that down no matter what projectile question you throw at me. I know AX is 0 and AY equals negative 9.8. The rest I'll adjust to the question. So here's the picture that they gave me. It looks like we're being launched from a cliff. How high is the cliff? Is that vertical or horizontal? So is that 50 going to go under the X column or under the Y column? But it's not going to be a 50. Ariana, shush, you had this last quarter, so it's fresher in your brain. Why would I not put, first of all, why would it be wrong to put dy equals 50? Are we ending up above or below from where we started? So Nick just rolled his eyes. Oh, I should have got that. So what am I going to put, Nick? Okay. There's one easy place to make a sloppy mistake when you're dealing with a cliff. Okay. I see that 20. Horizontal, vertical, or at an angle. So I'm going to call this Vx is 20. In my t-table, how many things have I written down on the left-hand side? 2. How many things have I written down on the right-hand side? 2. I need 3 things to find the fourth. There must be something else that I can infer. And I'll give you a hint. I know Vy initial. By far the most common mistake kids want to say, isn't it 20? Can you see why it can't be 20? That 20 is definitely horizontal. What? Loud and proud, Carter, you're on a roll. 0. Right when it leaves the cliff, it's traveling horizontally, but it hasn't started falling yet for that split second right when it leaves the cliff. Vy initial is 0. Which column do I know 3 things in? Vertical or horizontal? What does this want me to find? What's the first thing it wants me to find? Time. You might recall I made a joke last week. I said for projectiles, you know what you're going to spend most of your time finding? Time. Why is time so handy? Because it's a scalar, I can find it from either side. Okay? So how will I know which method to use? Whichever column I know 3 things in, that's how I'm going to find time. So I'm going to find time vertically. Do me a favor. I keep meaning to retype this. Put a little letter A above the flight time and B above the range. I want to be organized but lazy. What did you tell me we're going to find first? I just called that part A, so I'm going to go like this. Part A, T equals, and I'm going to put that in the vertical column. Just so I don't accidentally get tempted to use a horizontal here. I'm looking for an equation that has a VI, an A, a D, and a T in it. There is one. Which one? Loud and proud. Was that Wes? It's really tough when you're sitting side by side and I can't see your lips moving. I think that was, okay, good. I'm going to be just a little cautious because it's so easy to make mistakes for direction by putting a horizontal to a vertical, vertical to a horizontal. I'm going to write it this way. dy equals Vy initial t plus a half a y t squared. Why didn't I put a y on the letter t? It's a scalar. Oh, did I do extra work? What? Why? Yeah, I could have not even bothered writing that. So on the next line, let's go dy equals ay t squared over 2. Or you could write 0.5 ay t squared. I don't care. Wes, how would I get the t by itself? How will I move the a over? How will I move that 2 on the bottom over? And that'll give me a t squared. So if I hear you correctly, how much room have I got? I gave you the whole page, right? Good. dy just drops down like a domino. You're telling me the 2 would move to the front? the a would move to the bottom, and I would square root that. Okay? Now, do you remember when I asked you all, why would it be wrong to say d equals 50, and you couldn't remember? And then when I told you, are we ending up below, and you all rolled your eyes, went, no. If you had missed that, the nice thing is there's kind of a little bit of a built-in, clear that out of the way, error check. If you had gone 2 times 50 divided by 9.8, and then you tried to square root that, you get an error. Usually that's a hint. Go check your signs. You probably missed a subtle negative somewhere. Anyways, for all of us, what's it going to be? 2 times negative 9.8 divided, no. 2 times negative 50 divided by negative 9.8, square root of that. What do you get? You get 3.19438 there. Because I know I'm going to use time to find other stuff, I'm going to write it down to about 5 or 6 sig figs first, and then I'll round off. So I'm going to go 3.19438. And if I report that as an answer, 3.19 seconds. So there's my answer for A. It's in the air for 3.19 seconds. Doesn't matter whether it's moving sideways or not, that's its drop time. Josh, you okay with that? What did B want me to find? What's the range? If I look at the picture, ooh. Am I wrong, Carter? Oh, okay. What's the range? Look at the picture. Is the range horizontal or vertical? In fact, the range, you know what that is? That's dx. So I'm going to put B underneath the horizontal section and I'm going to go dx equals question mark. Problem. How many things do I know in the horizontal column? 2. So what? I know 3, Aiden? Because it's a scalar, it can go in both. Are you seeing why I said you're going to spend most of your time finding time? Or if the question gives you time, the question's going to fall apart. Because you now have one thing that can go in both columns. So T equals 3.19438. I'm going to use my answer button if I can. I'm looking for an equation that has a D, a VI, an A, and a T in it. There is one. Same one? No, really? Oh, like I gotta be honest, that would be kind of convenient. Although technically not exactly the same one. What's 0 this time? Do you see why it's so tempting? Noah, don't write this next bit down. For the people that do this, do you see why so many of them want to put the negative 9.8 there? Because you're so used to, I'm in free fall. That's always the acceleration. Only in the vertical direction. So horizontally, which by the way makes it a way easier equation. No squares or anything like that. It's going to be 20 times 3.19438, although I think I still have this on my calculator. Times 20, 63.9 meters from the base of the cliff. That's the range. On your test, I guarantee you, I'm going to give you what I call launched horizontally from a cliff, like this. And honestly, there's one of 2 things I'll do. I'll either give you the height of the cliff, find time, find the range, or I'll give you the range, find time, find the height. That one's way easier. How would I get the t by itself in this equation? Divide d by vx. But I got to be fussy. Divide dx by vx. Got to be careful now with our directions. And then you're done. Oh, and then you'd have time, and you could walk over to this side and find dy. You'd get a negative answer because you're ending up below from where you started from. It would work. I like example 9, I like example 9, I like example 9. Example 9 is a nice question. In number 9, we're launching from the ground at an angle. Did I say angle? Everybody. Components. Okay. Yeah? Okay. So before I even, oh, and by the way then, Carter, once we go components, we're never going to use that 100, that slanty one again. Not going to use it again. So the first thing I would do, I think I gave you a fairly big picture. If they hadn't given me a nice big picture, I would draw a nice big one, none of these postage stamp sized ones, but I think that's a pretty good sized picture. I'm going to go like this. D, that's Vx, D, that's Vy initial. There's my 9-degree angle. Kenna, why did I put an initial on the Vy but not on the Vx? Because A is 0, Vx is constant. Any chance I can have to remind myself of that, even subconsciously, I'll take that. Okay. That 100, opposite, adjacent, or hypotenuse. Oh, hang on. Color. Sorry. That 100, opposite, adjacent, or hypotenuse. Vy initial. Vx. Okay. You'll notice I really haven't started the question yet. Angles, components, before I even start. What do you want to find first, Vx or Vy? I don't care. Vx? Which trig function? Cos, of course it is. So it's going to look like this. Cosine of 35 equals Vx over 100. No, how would I get the Vx by itself? How will I move the 100 over? Yep. So Vx is going to be 100 cos 35, 100 cos 35. I get 81.9, oh, there's a 0 there. 81.9152 is a good place to round off, I think, with that 0 after the 2. 81.9152. Why am I carrying extra sig figs? Because they didn't ask me to find Vx. They asked me to find the time to top, the total flight time, and the range. I'll get to that. But for now, since I know I'm going to use these, I'll carry extra sig figs. 81.9152. Oh, by the way, what are the two physics no-brainers I could have written? What's Ax? 0. What's Ay? Negative. There's my t-table. Could have done that right away, I guess. Noah, what trig function was Vx? Anyone want to guess what trig function Vy is going to be? Really? Are you saying that Vy initial is going to be 100 sine 35? Are you saying on a test, would you write that? Yes. But are you saying in your homework, could you maybe have just backspaced, edited? And as long as you were really careful with the first one, cleverly said that's the second one, and 57.3576. Okay. Is there anything else that the picture has told me? Any other numbers that the picture gave me that I haven't used already? Say no. Okay. What does A want me to find? Time to top. How many things do I know in the horizontal column? I need 3. How many things do I know in the vertical column? I need 3. So I guess I can't solve this. Or can I? What else do I know? What does this want me to find, part A? I know something about being on the top. Which one? Did you hear what he said? at the top for a split second, still moving sideways, but my vertical velocity is 0. So let's put part A in the vertical column. And you told me that Vy final is what? And I can find time to top. I'm looking for an equation that it has an A, a Vi, a Vf, and a T in it. There is one. By the way, do you see that really, Cleo, this is Physics 11 again. Just we've added the components thing, but we've turned it into a Physics 11 question. That's going to be a lot of our strategy all year long is, can we turn it into something we already know how to do? Well, let's do that rather than memorize a whole new procedure. Some of you, if you have your own calculator, if it's programmable and you want to write, every once in a while I have a kid that has one of the graphing calculators and they write a projectile solver, go ahead, because you really need to know how to do the physics. If you're going to code it, go ahead if you want to write the code for it, but otherwise we turn it to Physics 11. Which equation? Vf minus Vi over A? Yes? Cool. T equals Vf minus Vi over A. Look up. Vertical, vertical, vertical. Just to remind myself, don't use that 100. It's not vertical. Common mistake, by the way. Kids will say, oh, Vi is 100. No, it's not. Not in my t-table, because it's not vertical or horizontal. 0 minus 57.3576. Noah, do you still happen to have that number stored on your calculator? How would you not? Isn't that the last thing we typed? Follow along. Do it on your calculator, okay? I have this on my calculator. So is this a fraction? Yes. Is there more than one thing on the top? Bracket 0 minus answer button divided by negative 9.8. You get 5.85282, blah, blah, blah. You know what? After that, 2 is a good place to round off, I think. So 5.85282. T top 5.85282 seconds. And if they want me to record it to 3 sig figs, 5.85 seconds is how I would report the answer, but I would jot down the extra digits somewhere. Or I would store them on my calculator if I was following along. Sorry for those of you at YouTube. I just realized I leaned forward right into the microphone when I was bellowing that. If you're listening at home on headphones, I apologize. You guys should see the comments I get sometimes when I do one of my yells. They're great in my YouTube channel. I get some great comments. Cool. Cool. Mark, what's B want me to find? What was that? Are we starting on the ground? Are we ending on the ground? Then yes. By the way, could I use that clever shortcut trick for this question? No. That's why this is by far the toughest one to find time for. So I agree. I got two options. I could double, since I found time to top, I could double it. So I'm going to write part B here. Since time is a scalar and it can go in either column, I'll say T total equals T top times 2. Noah, do you have this number stored on your calculator? Good for you. Times 2. And I get 11.7056456. I'll go 11.7056. Or 11.7 seconds. Again, I have a feeling I'm going to use this, which is why I carried the extra sig figs, just so I would be more accurate. What if I hadn't found time to top? What's another way I could find the total flight time? Okay, put your pencils down, look up. I would never do it this way, but you could use that. Don't write this down. Where, what was VI, vertical? Give it to me to the sig figs, please. 3576 T, and then minus 4.9 T squared. I did half of negative 9.8 in my head. How high were you when you started? Don't write this down, Noah. You write the T total down, but don't write the next bit down. How high are you when you finished? What's your displacement? What's your change in position? If you started at 0 vertically and you ended at 0 vertically, what's your vertical displacement? You could solve that quadratic using x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Ugh. That would work. Or you could realize that Vy final when you hit the ground is negative 57.3576. And then you could plug it into this equation, but instead of 0, negative 57.3576. Which, by the way, Noah, if you happen to have that number on your answer button, you would actually go bracket, negative answer button minus answer button, close bracket, divided by negative 9.8, which is pretty quick to type, actually. Okay? So, or use, if you want to, you can write that part down. Other Josh, what's C want me to find? Horizontal? Okay. So you're saying C wants me to find dx. Uh-oh. I only know two things. Or do I? What's the third thing that I know that I can put in this column? Which one? The 5.85 or the 11.7? Because that's my total flight time. Common mistake that kids make. The kids that find the time to the top and then double it, they often forget to double it, and they use that for this as well. So just be cautious. Think things through. So T is 11.7056. Which equation? dx equals vxt? Just like before? Oh, like that. So it's going to be, what was Vx? 81.9152. All right, 11.7056. But Noah, can you and I hit the answer button? I can. 81.9152 times answer button. And I get 958.8, you know what? 959 meters, almost a kilometer. By the way, it was doing some of this math and wanting to do it very quickly that led to the development of some of the first earliest computers during World War II. They wanted to be able to fire artillery. For the longest, for a time, it was known how long it would take you to calculate this by hand. And troops had a habit of just, you move before you know that the other group has been able to calculate how high to raise their cannon and how far to shoot. So you would just get in the habit of moving because you know it takes about 8 minutes or so to crunch the numbers. We'll move every 7 minutes. So the idea behind having a computer was, if we're at the front, we can radio the enemy's coordinates back to headquarters. They can quickly crunch it on a computer, come back to us, azimuth of 38 degrees, point it that way, fire. So this was some of the earliest, I guess, Cold War or real war technology battle. Okay. Next class, we are going to tackle cliffs at an angle. In other words, we'll combine horizontally from a cliff and ground at an angle. That's by far the trickiest one, but for now, your homework, try number 1. I've given you one diagram and just given you 4 different questions to try. Okay. Number 2. Look at part C. What's the angle for 2C? I think you'll find that your Vx and your Vy there will be identical because a 45-degree launch gives you a horizontal and vertical component that are identical. If you're bored, if you play around with the numbers, you'll also realize that gives you the longest possible range. And anyone who's ever played quarterback or thrown a baseball has figured this out intuitively. If I want to throw it as far as I can, you try and aim it for about 45 degrees. That's the sweet spot. Right? If I want to throw it as far as I can, I'm not throwing it like that. I'm not throwing it like that. You all figure this out when you're kids and chucking stuff around. There's physics behind it. Anyways, number 2. Number 3 is a thought. I'll talk about it next class. 4 is good. 5 is good. 6 is good. 7, 8, and 9, these are good examples of some of the written questions you might get on these. So 7 is good, 8 is good, 9 is good. If you want to start whittling away at the ultimate review, because we're nearly done the unit, I got one more lesson and some quizzes. So I'm thinking right now your test, I'm aiming probably for not this upcoming Monday, but the following Monday, maybe Friday. I don't know. We'll decide as a class if you feel ready. But you can start to whittle away at the ultimate review. Okay?